Alrighty, I want to look at number 7 and then the challenge problem on the whiteboard activity here. Whenever you think about number 7, I gave you a hint that we should probably split up the integral so that there are two parts. And the reason why is because if I were to look at this and think about, hey, if I do u sub, I can't really do u sub because I can't cancel out the minus 27. But I can't really do inverse tangent because I need a constant in the numerator. So what we're going to do is do both by splitting up the integral into two parts, aka x over x squared plus 1 minus, dx, minus 27 over x squared plus 1. So looking at this integral right here, we could use regular u sub and then do 1/2, well, 1 over 2x over x over u du. The x's will cancel out, so now we have 1/2 the integral of 1 over u du, which then gives us 1/2 ln of x squared plus 1. And that's the first part. Then looking at the second part right here, this is just regular inverse tangent, where you know that u squared is x squared, a is 1, so u's x, a is 1. So then you would just do minus 27 inverse tangent of u over a. 1 over a is just 1, so that's why I didn't really do 1 over a. And this gives us our answer for number 7, aka just splitting up the integrals, integrand. Likewise for for the challenge problem, we are going to split up the integrand into two parts. Well, first, maybe not. We'll see. There are a couple of ways that you could do this in terms of splitting it up first, but what I'm going to do is think about how we could use u sub first. And then a lot of us stopped here just because 2x plus 6 can't really cancel out till 2x minus 3. However, what we could do, though, is think about, we can technically cancel out the 2x plus 6 if I have some sort of 2x plus 6 on top, which is what I wrote as of right now. The only problem is that our original function is in terms of a 2x minus 3. So I need to figure out a way to get 2x minus 3 given that I have 2x plus 6 right now. In other words, I need to subtract 9. That way this is the same thing as that. So now what I'm going to do is split this up into two parts. The first part's where I'm just going to use regular u sub here. And then the second part's where I have the integral of 9 over x squared plus 6x plus 34. I keep on forgetting about my dx's. Okay, so u, once again, is x squared plus 6x plus 34. du is 2x dx. Well, 2x plus 6 dx. So then that gives us the integral of 1 over u du, which gives us ln of x squared plus 6x plus 34 in terms of the first integral. And of course, plus c, but we're going to use plus c at the very end. Now we have this integral right here where we have 9 over x squared plus 6x plus 34. Now, remember in the video, we talked about how if something looks like this right here, we should probably complete the square. So I'm going to rewrite this in terms of the integral of 9 of x plus 3 squared plus 25. I cannot reteach you guys how to complete the square, so make sure that you know how to complete the square. So then you know that your u is going to be x plus 3, your a is going to be 5. So now you have 9 times 1 over 5 inverse tangent of u over a, and then plus c. Of course, I could probably do that here. Call it a day. So your final answer is going to be ln of the absolute value of x squared plus 6x plus 34 minus 9/5 inverse tangent of x plus 3 over 5 plus c. So you will potentially have these types of problems on either your quizzes or your tests in terms of where you probably have to split up your integrand. So make sure that you know how to do that. In addition, sometimes, just like what we did last week, you might have to use long division, or you might have to use synthetic division. So for something like for this one here in blue, where I just flipped the integrand right here, you're going to have to use synthetic division. So at this point, your quiz and your test, it's going to be a game of, do you know what method to use?